This is the first version of the light array circuit. It starts with this 555 timer in astable mode, used as a clock signal. The potentiometer changes the rate at which the capacitor is discharged, which affects the clock rate, so it can be increased and decreased within some range. The 555 timer feeds its clock output into the Johnson counter, which is wired, each output is wired to an LED. Some LEDs have more than one output, which is what the diodes are for. They ensure that one output doesn't feed back into a different output, which caused problems in my experience. The control stage of this is the one found in the lab manual, with just a PNP and NPN transistor feeding one to the other. This is able to supply enough current to quickly charge up the capacitor, so it has a rapid on appearance for each LED in the next stage, but it also gives the capacitor a way to discharge slowly whenever it is turned off. So the final stage just has each LED has an identical circuit, which enables the LED, and then slowly the capacitor keeps the BJT switching circuit enabled until it's run out of power. Here you can see the clock signal in yellow and the voltage across the LED in blue, which demonstrates the rapid turn on of the LED, and then it slowly dims out as the voltage is discharged from the capacitor. The main problem I encountered with the original circuit was that even in the low state, the Johnson counter was outputting just barely enough voltage to turn on the transistor. So I had the help of AI figure out a voltage divider biasing setup for the middle stage, so that it would ensure that the base only received turn on voltage whenever the Johnson counter was outputting like 6.3 volts. So its high state would be the only case in which it was activated. This is the light array circuit with AI modifications. The main problem I was encountering with the original design was that the low state on the Johnson counter, so in between flashes, was still outputting high enough voltage to kind of randomly flash the LEDs sometimes. So it was like just barely, 690 millivolts, which sometimes turned on the transistor. So I had it modify the middle stage with a voltage divider biasing, so that the base would only receive turn on voltage whenever the counter was outputting, 6.3 volts. So like its high state